Hallo, meine sehr geiles Freundin. Here is immer noch dein sehr guter Freund Sam, and it's time for another Maximus P tutorial. So today we're going to do another really awesome video effect. In fact, of all the ones that we've been looking at lately, this one's probably my favorite. Although I should warn you, you will need both Max 6 and Gen for this one to work. You will need all the latest and all the greatest, which if you don't have, what can I say, man? I thought you were the coolest experimental VJ on the block. You gotta have the coolest software. But in any case, it is a really cool technique. Basically, we're going to take an image and distort it in a way that kind of apes the effect of pouring the image over a bumpy surface as if it were a liquid or a soft wax or a nubile young person or something. That came out really weird. I apologize. In any case, let's get to the patch. So make a toggle, make a Q metro. This is just the boilerplate stuff, you know, just the things you would have to throw in the patch any old time to make some stuff happen. The Q metro to send out your bangs 60 times a second to calculate all your frames. A jit.window with a good Teutonic name like @name Heinrich. Yeah, @name Heinrich. And there he is. There's good old Heinrich. You also have to have a key and cell 22, no, 22, I don't know what 22 is, it's cell 27, a toggle, and a, not a message, not an object box, a message box that says full screen $1, dollar bills, yo. Connect those up, and then now we can go full screen, very exciting. Also make a jit.gl.render because we will be using not only, like I said, we'll be using jit.gl.pix to do this, so we need OpenGL. @draw to Heinrich, or whatever good Teutonic name you picked. Hans would work. Ul is a good name. Trigger, bang, bang, erase. Great, very exciting. So Q metro, this first bang actually does the rendering, or rather this first erase erases it, next bang does the rendering. Also make a send pre-render, and this will be used to do all our calculations before we actually draw our matrix. And now if we hit this Q metro, nothing happens. Why does nothing happen? Because I didn't spell Heinrich right, I missed an N. So now, yeah, you can see this is turning a slightly lighter shade of gray. That's good. So the next thing that we're going to need is the jit.bfg object from the last tutorial. Jit.bfg, as you remember, stands for Big Fuzzy Graphics. And what it does, if you don't remember from the last tutorial, is it makes very fuzzy, lovely noise. So instead of making the annoying, angry noise from jit.gl.noise, it makes this lovely, fuzzy, watery noise that makes you think of calm, happy places like beaches and bedrooms and record stores and that kind of stuff. So go ahead and copy these objects, the jit.bfg, the jit.normalize, and all this offset and scale stuff here. Copy that, close the help file, and paste it into your patch. Now, the next thing we want to do is actually draw this thing just so we can see what it looks like. So to do that, the first thing we have to do is the output of this jit.bfg is a matrix that has x dimension, a y dimension, and a z dimension, even though that z dimension is 1. Jit.window can't display that. So make a jit.matrix and give it the args 1, float 32, 256, 256. Connect that to the output of this jit.gl.normalize, then make a jit.gl.videoplane. Videoplane is just how you display a matrix in OpenGL. Sorry, it's how you display an image in OpenGL. Also give it the attribute @transformReset2. This tells this jit.gl.videoplane, or rather it tells the OpenGL context that when it renders this video plane, it should ignore the current transform. The transform is what OpenGL uses to position objects in the world, and by setting transform reset to 2 here, you're telling OpenGL, when you render this video plane, just draw it. Don't try to put it anywhere in the world of OpenGL. Just put it in front of my big stupid eyes. So anyway, yeah, go ahead and connect this matrix up to the video plane, and then finally make a receive pre-render that will bang on this jit.bfg, and if we turn on rendering, we should see our noise in our GL window. We don't, probably because I'm a doofus and didn't click this basis noise gradient. There we go. Now it's actually generating the noise. Or rather, it's actually making noise that we can see. And why don't I make this window floating? I think that would be helpful. Or maybe I'll just make the max window smaller. How about that? Cool. So now you can see we've got our window here, and if I play around with the offset and the scale, there's our noise in our window. So now what we want to do is treat this not as if it were an image we wanted to draw, but rather a surface we wanted to extrude an image around. What we're going to do is take an image and distort it based on the slope of this image here. What do I mean by the slope? Well, imagine you were looking at a topographical, topo something map, and these white parts are peaks and these black parts are valleys. And what the slope is just at any point, if you were a marble or a person curled into a ball, and you were sitting on a part of this graph or matrix, which way would you roll? Which way would you roll? Left, right, up, down? And the way that we're going to calculate that is very simply just by taking the point to our right, subtracting it from the point to our left, and the point above us, and subtracting it from the point below us. Sounds simple, that's because it is. So we're going to do that, we're going to do it using the jit.gl.pix object. So make a jit.gl.pix, put it over here. Go ahead and actually also make a jit.matrix. Give it the arguments 4, float 32, 320, 240. Connect that up like so. Add it in a message box that says import movie, and go ahead and find a movie. Find a movie on your computer somewhere. I'm going to use, no, it's not a good one, no. I'm going to use this picture of a beer that I had in Scotland. I think that's going to be a good picture. And then connect this pre-render up to this jit.matrix so that on every frame now we will be first banging out the noise and then banging out this image. And jit.gl.pix by default just adds 2 images together. So if we hook things up, there's the beer and here's the noise kind of thrown on top of it. So jit.gl.pix is just right now just adding together that image and this noise. We want gl.pix to do something a little bit more sophisticated though, so go ahead and double click on your jit.gl.pix to open it up. Delete this plus right here. Now, what we're going to do is take this input matrix on the right, the noise matrix, and sample it at points to the right, left, top, and bottom of the point that we're given. The coordinates of the point that we're given come from this object called norm. Norm gives normalized coordinates, or coordinates between 0 and 1, describing for each, remember that gl.pix, I should say, what we're looking at here, gl.pix is going to do a big operation for the whole matrix. We, as the user, we define what should happen for an individual pixel, and then gl.pix will do that for the whole matrix. So right now, imagine we're looking at it, we're thinking about a single pixel. In 1 is the pixel value of that pixel. In 2 is the pixel value, in red, green, blue, alpha, of that pixel. Norm is the normalized coordinates between 0 and 1 of that pixel. So, given the point in normalized coordinates, if we want to compute the point a little bit to the right, we would take that point and add a small vector to it. So I'll make a new vector, 1, 0, and we're going to scale that by a parameter that I'm going to call delta x. Let's just call it dx. We'll make dx by default 0.01. Now we're going to multiply that vector by this dx parameter, and then both add it and subtract it to the input normalized coordinates, like so. Hopefully this is all making sense. So this represents a point a little bit to the right of the input matrix, and this is a point a little bit to the left. If we sample that matrix at each of these points, like so, bring the into down here and connect it to each of these, we now have the height of the point a little bit to the right and the height of the point a little bit to the left. And we can now subtract these, and this gives us the slope in the x direction. I know, really cool, it was that easy. To get the slope in the y direction, we just copy this whole big mess, with a few small changes. Instead of parameter dx, let's make a parameter called dy. Instead of a vector that is 1 in x and 0 in y, we'll make one that is 0 in x and 1 in y. And that's actually it. So here is our x slope, here is our y slope. And if we take these, I'm going to add them, I'm going to pack these into a vector, so vec x, y, and then multiply this by yet another parameter I'm going to call scale. So param scale, let's make it 1 by default. And then we multiply these together. And finally, once again, take the normalized coordinate, add that to this scaled slope value, and sample the input matrix on the left based on this pixel value. And what we do in fact see here in our window, which is really cool, I'm really happy this worked out the first time, is a super distorted version of the original image based on this noise. So if we make a jit.p window, and I think this effect is actually a little extreme, so if I turn down this, let's go ahead and make a floating point object here, param scale $1, so that we can change the scale, maybe make it a little bit less pronounced. I'm going to make my scale 0.1, a little bit bigger. Yeah, so let's see. You can see there's kind of a big big lump over here, or like a big change in the slope over here. And indeed, in our image, that's where a lot of the action is happening, which is pretty cool. So this is okay. This is a slightly interesting effect, but it's about to get awesome. And the way that we're going to make it really intense is using, you guessed it, feedback. So what I'm going to do, delete this patch cord here, move this matrix over here, and now let's get a named matrix up in here. So now whenever I import a matrix, I'm going to store it, or rather import an image, I'm going to store it in a matrix called jit.matrix, give the arguments for float 32. Actually, you don't need to do it. Yeah, float 32, 320, 240, at name Carl, K-A-R-L. And connect this matrix to this matrix, like so. Also give this matrix the attribute at through 0. This makes it so this matrix will just store the current image and won't output it until we send it a bang. Connect this to the left input of this jit.gl.pix, and finally copy this matrix and put it down here so that when jit.gl.pix is done rendering, it stores the matrix it rendered back in this matrix here. You can delete the at through 0 here. So now this pre-render comes through. Every time we go to render a frame, the first thing we do is take this matrix Carl, pass it to this jit.gl.pix, distort it a little bit, and then store that same matrix back in here before writing it to the video frame and actually drawing it. So if we import a movie, let's import where's that beer? There, it's an even better picture of that. This is another picture of that same beer. Why did I take so many pictures of that one beer instead of drinking it? Hit this bang here, and look at that. Was that or was that not really cool? So here's our input image. And if I turn the scale down to 0.01 maybe, and hit this bang again, you can see the image is like slowly distorting. The pixels, the colors are kind of like converging into different cells, and oh man, I think the result just looks so cool. Is that not really cool? You can turn up the scale a little bit, and actually if you turn the scale up a little bit high, medium high, to like 0.5, maybe 6 or so, and then hit this bang again, you can actually get these cool zones of kind of like color swirls. Like look here, this is like rippling. Let's move the noise around a bit. Like so, and then hit the scale up to like 0.7, hit the bang again. Yeah, look at it, isn't that cool? I really love this effect. And you can even work it out so that, like if we hook up a Metro 750, oops, give this a toggle, and then hook it up to this bang. Now it's like this cool kind of, we've got this rhythm going on in our image that's really nice. You can also hook up a counter here with an argument 3 maybe, so that we have like 3 different noise matrices that or 4 different noise matrices we choose between. So you actually have kind of meter now in your video. 1, 2, 3, 4. Yeah, I just think this is a really cool effect that you can play around with basically forever. But yeah, with different noise, you can adjust the scale. You can, I mean, look at that. Come on, that's awesome. Move the scale to a different value. Make the scale negative, positive. I just think there's an endless amount of stuff you can do with this effect, and it's really super easy to pull off. So anyway, that's the extent of this tutorial, actually. I guess it's relatively quick, but yeah, I hope that's cool and useful as always. And thanks for watching. I really appreciate it, and I hope that was hope it was useful. So yeah, as always, if you're in Berlin and you want to talk Macs, hit me up. And also, I'd love to do a Macs workshop or a Macs class or something here. So if you know of a space or you know somebody who'd be willing to host, I would really appreciate it. And yeah, get in touch about that and let's make it happen. So thanks again, guys, and auf Wiedersehen. I will see you next time.